Okay, think about this for a second. Have you ever wondered about the exact, totally unseen moment that actually birthed the modern AI revolution? I'm talking about that quiet, almost invisible spark that eventually gave us massive tools like ChatGPT, Claude, and Gemini. Well, in today's explainer, we're popping the hood, we're looking right inside the engine of modern AI, and the best part? We are going to do it with zero math. Seriously, not a single equation. Instead, we're going to build some really powerful mental models that will honestly just make all of this click into place for you. So, picture the year 2017. A group of 8 researchers over at Google published a 31-page paper. Now, you know as well as I do, hundreds of papers get published every single day in this field, and most of them just vanish without a trace. But this one quietly changed the whole world. It had this remarkably confident, almost audaciously simple title, Attention is All You Need. And buried inside those 31 pages was a paradigm-shifting idea that literally reshaped everything we thought we knew about computing and language. All right, let's kick things off with Section 1, the problem with old AI. To really appreciate just how massive this breakthrough was, we've got to understand the hard ceiling that researchers were banging their heads against right up until that 2017 paper. Specifically, we're talking about the severe memory limitations of early language models. Think about this really simple sentence. The trophy didn't fit in the suitcase because it was too big. Okay, simple enough for you and me, right? But I challenge you to think about what's actually happening in your head. How does your human brain instantly know that the word it refers to the trophy and not the suitcase? You just naturally, automatically trace the word it all the way back to the word trophy and ask yourself, well, which one is too big? The computers back in 2016, they were absolutely terrible at doing that. And the reason is they relied on something called a recurrent neural network, or an RNN. This was pretty much the dominant AI architecture before 2017. You can basically picture it as a system that read sentences strictly left to right, word by word, with a terribly, terribly short memory. By the time it sequentially plotted its way down to the word it had practically forgotten all about the trophy. It simply couldn't make that leap backward to connect those dots. Which brings us to Section 2, enter the attention mechanism. So that whole left to right struggle, it created a massive bottleneck. Those Google researchers looked at this limitation and asked a really bold question. What if there was a completely different way to read? The solution they came up with is kind of like a crowded party. I want you to imagine you just walked into a massive party, right? 100 people all talking simultaneously in the same room. Now, when you're standing there, you don't hear all that noise equally. Your human brain automatically filters it out. But if someone all the way across the room says your name or starts talking about your favorite hobby, you instantly tune in. Your attention isn't just random, it goes intelligently to exactly what matters in that specific moment. And that natural, intelligent filtering is exactly what the transformer architecture does with words, using a mechanism called self-attention. Instead of reading sequentially, one by one, the system just takes in the whole sentence at once. And for every single word, it calculates exactly which other words matter the most. So, when it's evaluating our earlier sentence, it's looking at it, trophy, and suitcase simultaneously. It weighs all the context clues, and its attention focuses heavily on trophy. The sentence is quite literally paying attention to itself. Let's make this even more concrete. Imagine a 10-word sentence is just a 10-person meeting room. The old way, the RNN, was basically like playing telephone, passing a note one seat at a time. The first person whispers to the second to the third. You know how this goes. By person 10, the message is completely garbled and half the information is gone. But the new way, the transformer, it's like every single person in that room is sending a direct message to every other person simultaneously. Not sequentially, simultaneously. Every single word is evaluating how much it should pay attention to every other word, all at the exact same time. Moving right along to Section 3, the power of scale. Because of this genius new architecture, we totally bypassed that old clunky left-to-right machinery. Attention really was all they needed. But this brings up a huge question. Why did this one specific invention from 2017 cause such an explosive boom in billion-dollar AI investments? Like, if attention is so amazing, why wasn't anyone doing this before 2017? Well, the answer is compute. Having every single word talk to every other word simultaneously requires a massive, massive amount of computational power. It is incredibly expensive to run. It was only finally unlocked because new GPU hardware had improved just enough right around 2017 to actually make it feasible. Just think about the staggering leap in AI model parameter scaling over the last few years. The truly transformative insight here wasn't just that the architecture worked, it's that it scales. Old architectures used to just hit a wall, but the transformer, it just keeps getting smarter and smarter as you throw more data and more compute at it. I mean, look at the numbers. GPT-1 had about 117 million parameters. GPT-2 jumped to 1.5 billion. And then GPT-3 absolutely rocketed to 175 billion. And here's the kicker. It's the exact same fundamental architecture, just bigger. And scaling up didn't just make these models a tiny bit better, like slightly faster or slightly more accurate. It unlocked what the industry calls emergent capabilities. As you scale up, qualitatively new abilities suddenly just appear out of nowhere, things the smaller models couldn't do at all. It's not this nice gradual improvement curve. It's like suddenly crossing a threshold into entirely new and honestly sometimes totally unpredictable capabilities. Nobody fully predicted it would work this well.
Okay, let's ground this a bit in Section 4, Practical Limits and Reality.
Because obviously, this technology isn't magic, right? It has actual bounds. Let's bring all this theory down to earth and see how it directly affects the AI tools you're probably using every day. First up, the context window. This perfectly explains why your AI sometimes just loses track of older parts of a really long chat. It's because there's a strict limit to how much text it can hold in its attention at once. Eventually, the older parts just fall out of focus. Next, finite attention. This limits how well models can process massive things like 100-page contracts. The attention mechanism is super powerful, but it's finite. And finally, predictable scaling. This explains the breakneck pace of AI progress. As compute gets cheaper and the architecture scales predictably, the rapid improvements we're seeing, that's actually a structural feature of the tech, not just a random anomaly. Now, before we wrap this up, I want to pause for a second for a crucial moment of honest humility. You're going to hear a lot of people out there speak about AI with absolute 100% certainty. But the real truth? Even the researchers who literally built these systems don't fully understand everything they do. When a massive transformer suddenly develops the ability to do multi-step reasoning, we have hypotheses, but no complete theory. The truth lives in the honest middle. We have to balance being genuinely excited by its unbelievable power with a real understanding of its genuine limitations. So how do we lock in what we've learned in this explainer today? I want you to try the grandmother test. Can you explain the attention mechanism to a totally non-technical friend using only that crowded party or the meeting room analogy? Seriously, try it. Teaching is absolutely the deepest form of learning. Find a friend, ditch all the jargon, and see if you can explain how every word pays attention to every other word simultaneously. What part of the analogy are you going to use first? And I'll leave you with this thought. If this one simple mechanism of attention managed to reshape our entire world in just a few short years, what in the world do you think the next breakthrough is going to look like? Thanks for joining me on this explainer.